My name's Les Carr. I run the Doctoral Training Centre here. Say hello all the DTC students. Yay! Yeah, you're getting the hang of this well. And Elena asked me if I'd introduce Jim Hendler to you today. So, and I thought, as a web scientist and as Jim is a very prominent person in the web community, I thought, what better way to do that than to let the web speak? So I've asked Google who Jim Hendler is, and I would like to, I can verify that we do actually have the right person here. Although I think you'll see that. I think you'll see in the lower far corner that Jim is one of these people who was alive when the world was entirely in black and white.
I still have hair.
So Jim Hendler, or Professor James A. Hendler, is let's see, Tetherless World Senior Constellation Professor Director, Hendler Institute for Data Exploration and Applications. Well, anyway, so or the Tetherless World Professor of Computer and Cognitive Science at the Assistant Dean for Information Technology and Websites. That's much clearer. Okay. We'll see that he's been verified by Google Scholar Citations, has a verified email at RPI, which is fantastic. So we know that we're dealing with a genuine person. We know that he looks like the person who's turned up, and that's fantastic. And on Twitter, which is of course not to be trusted, we find out that he's a semantic web geek, a web science evangelist, an open data nerd, and a big data lead, usually in the USA. And that's often because you'll find that he can't fly out because there's something wrong with the planes that he gets on. And there are long stories about that. Although if you turn to Wikipedia, you find that Jim Hendler is an artificial intelligence researcher at Rensselaer Polytechnic Institute.
Thank you for finishing that sentence.
Well, you see, you have to be very careful about provenance on the web and understanding all of these reasons. And you see a slightly different Jim Hendler emerging from all of these things. So we see that he's an inventor of the semantic web, according to YouTube, which is, you don't see many people taking responsibility for that, but that is apparently on our speaker's shoulders. And then we find out that the semantic web for the working ontologist shows how the semantic web builds on the same Jim Hendler. So I'm not entirely sure about what he is. And we also see that Jim Hendler is the head of the Computer Science Department at Rensselaer Polytechnic Institute. Please enable JavaScript to view. So if you are finding problems with following him, you need to enable your JavaScript. Then you'll see it better. So what is this person? You know, is he an artificial intelligence? Is the semantic web built on him? Why does he need JavaScript? We also find some terrible accident that he had been wrongly fused with another entity. And so no wonder there's some mismatch about him here. He's apparently very well known by IBM's Watson. He speaks knowledgeably in the Washington Post about the future for IBM's Watson. And there is a web agents group has asked whether there's an intelligent agent in his future from quite some time ago. And but when Quora was asked about him, Quora replied that he's a great guy. I think it's very unfair to call him an old, but let's just say the first person who ever showed Quora the World Wide Web. Jim is a founding director of the Web Science Trust, and so he is a really important guy to us. We've known him for a long time in Southampton. He's been involved in many of the research activities that we hold dear. And I hope, like LinkedIn, you see LinkedIn says that LinkedIn is the world's largest business network, helping professionals like James Hendler. And I hope that you will as well. You will like James Hendler at the end of this highly enlightening talk. Thank you very much, Professor.
Les.
Yes.
should have queried Jim Hendler and Playboy.
Oh, no. That's smart enough to know we don't do that. In the 3 minutes I have left, no. I was throwing slides together last night somehow and then put the wrong title. So I talked at another summer school last week, and that was the title of the talk I gave there. So, and I'm going to actually, I fused the talk I was going to give here and the talk I gave there because the original schedule had me with significantly more time than I ended up finding when I got here. And since we spent some time wandering around campus because I was going to make some joke about ambiguity in the web. Say that Southampton has really embraced that with 2 buildings numbered 45. But yeah, so that's actually, so Les mentioned a lot of different titles, the Web Science Dean and the Chair of Computer Science. Those are old titles. Every year they like to change my title at RPI so that no one will ever get complacent about who I am or what I do. So I'm now the director of our Institute for Data Exploration Applications, and making sense that I'm here at an age of data summer school, but since some of the web science work we talk about derives from stuff we were doing some years ago, and semantic web, I thought I would try to kind of mungle a whole lot of that together. I also thought I'd start with this. Some of you saw, I noticed several of you had tweeted Wendy Hall's picture of the web science stack, the semantic web stack, from Tim Berners-Lee's 2006 talk. My 2009 talk, we expanded it a little, and I'm not going to give that talk today, but you can watch it on YouTube. We'll make the slides available somewhere, or just Google Hendler layer cake, because it's the only talk I've ever gotten a standing ovation for, and it's because I did it completely in rhyme. So I'm not going to do that today either. But this is really what I'm going to talk about. So. This thing about inventing the semantic web is actually, there were a bunch of us working on this stuff. And 3 of us, Tim Berners-Lee, myself, and Ora Lassila, wrote this article about it that showed up in Scientific American that's become sort of the standard vision article for what the semantic web is. And this is actually the original outline we sent to Scientific American. And that thing in the middle is based on a very famous cartoon at the time, where you see these 2 scientists standing in front of a blackboard, and there's a bunch of equations here and a bunch of equations here, and then in the middle it says, then a miracle occurs. And one scientist is saying to the other, I think you should be more explicit here in step 2. And we were working on this, and we sort of had figured out, kind of who was going to be writing what about the beginning part, and where we wanted to go. And there was sort of this gap in the middle, and Tim just walked up to the board and typed, wrote that a miracle occurs, and we all knew what he was doing. Sure, we'll do that. But what he was really saying, and those of you who've seen the famous Web Science Circle know that part of the philosophy of the web is you have to think about getting things right sort of in small and engineering them, but also think about how they expand and build, and that stuff in the middle is sort of the stuff of magic. Right? We're never quite sure which apps are going to work, go large, go viral, which videos, things. I was particularly taken recently by something I saw in The Economist. I would show you the slide, but their copyright policy, you have an online form you can fill out to get permission to use it, and then it's supposed to tell you how much it costs. But it couldn't handle academic talk, summer school, any of those things. But they looked at how much time people have spent watching the Gangnam Style video. Okay, it comes to 140 million person hours, which in that amount of time you could build the pyramids of Gaza 4 times over. Okay, by the time modern technology came around in the early 1900s, you could build the Empire State Building, at the time the tallest building in the world, took 7 million person hours. Okay, so you could build 20 of those in the amount of time people have spent watching Gangnam Style. So that miracle of sort of what will be the Gangnam Styles and what will be the things that, like my video, if you go to that layer cake video, I think it's had 11 watches by now. What makes the difference? And
a lot of it is, again, thinking about what the web is about. So I'm going to do like this 2-second version of what the semantic web is. I then luckily took out about 20 slides from that last talk because I figured I wanted to get everything into an hour, and now I'm trying to get it all into about, I think I have 10 minutes left. We'll probably go a little longer. This is what we're trying to do. So the basic idea of the web is very simple. You've all seen this. You have a web page, and it points at another web page. So technically, those of you who have played with any HTML or have ever sort of accidentally opened a source view on a website or anything like that, know that the little language at the bottom of the web says that the way one piece of the web talks about another is it creates a link. So you have this thing called an anchor, and it refers to another page. And then over in that other page, you have the thing you're pointing to. So I can say, this is a picture of my kitty cat, and then I have the photo, and then I put this little link in between my page and that photo, right? And that way people can see my kitty cat on the web, and since 90% of the early web was about kitty cats, that made great sense. Okay, the only thing that people have looked at more than Gangnam Style is cats doing silly things. So when we came to do the semantic web, and the language that was sort of at the base of the semantic web was something called the resource description framework, based on another language I'll mention a little later. The idea was, why don't we label those links? Now this actually wasn't a new idea. The web was postulated by Tim in '89. By 1991, some code was floating around called libwww. It was a little C package. You would stick this thing on your system, you would configure it, you would go down and tell your system administrator that he had to put this thing on the system or he was fired. He would call his boss would say, if the professor said you had to put it on, you have to put it on. He'd put it on, and voila, you'd have a web server. Right, so that's really, in a sense, that was before Mosaic, that was before the browser. That was the thing that kind of let the early webbies start playing. And literally within months of that thing coming out, people were already discussing, shouldn't we be able to label these things? Because if I'm looking at something like, I'm looking for the web page of a person named Fred Cook. Right, I'm looking for something about a hobby of cooking. I'm looking for a cookbook, right? The words in English being ambiguous, it'd be nice when you're looking for links on the web to be able to categorize them better. So the idea was, what if we had a way to say this is a name or this is a person? So if you followed a person link, you'd be using cook in the concept of a person, so at least if you're going to, the original idea was to be going to people named Cook. Although later the idea would be you'd be going to either a person named Cook or a person who was a cook, so we wouldn't have to get it all right. And there was a proposal for 10 of these, and 15 of these, and 50 of these, and 6 of these. So these were floating around for a while. The World Wide Web Consortium in its early days, mid to late 90s, I forget the exact date, let's say we're in the 15th anniversary now, something like that, had something called the Meta Content Framework working group, which was going to try to get this right, and they eventually published a thing no one's ever heard of, and then they got turned into what eventually became this RDF. And the big realization was, look, what you really want is a scheme on the web where if the two of us decide we want to name something, a kind of link name, we'll just make it up. And if the two of us want to have a different one, we'll just make it up. And the only thing is we want to make sure we don't get confused. So if he and I have a cook link and he and I have a cook link and we want to talk about cooking and we want to talk about people, we'll just give it whatever name we want. And we want an unambiguous name. So why don't we use the name http:// and then the name of the server, and then the name of whatever file we want to keep these terms in. So this would just be sort of a fake name, but we'd use the infinite naming space that is the web. So we would therefore have a web page would point to anything else on the web by a label that would look just like a web label. And if you get that idea, you've now got almost everything you need to know about what the semantic web is really built on, why it was hard to make the semantic web get out there, because of course the whole web had already been built on these unlabeled links, and now we're trying to get these labels on things, needed some infrastructure and stuff. But pretty quickly, people realized there's an even better reason to do that, which is if you're using these web names to name the links, And those web names could be web pages. So you could have a thing that a person can look at which would describe the link. So he and I put in our page, http:// you know, Southampton, so-and-so, names, links, Cook, right? And if you go to that page, it'll say, Cook is a person, and we're using it to list the people whose names are, last names are Cook. And if he and I do it, we could have something completely different, okay? So now you can have a document that you can have something like this on your web page. Okay, so this is, and I'm using a shortcut instead of typing http://. You know, I know enough of you are DTC students that you know what short names are. I don't know all of you have. I know from the summer school many of you have different backgrounds, and it's just a web shortcut. So this just each of these just pretend I'm just taking some very big URI and making it look like this. So that first YouTube URI where I gave you the layer cake thing and it said it's YouTube, and then these funny numbers, I could have just called that, you know, YT or YouTube or something. And those of you who are used to seeing short names now on the web, a lot of people actually have made that a standard way of doing things. But this is, so this basically says, on this document, I'm saying there is something called a person, as defined on this thing called mind, which again would be a particular page, whose ID is Hendler, and his title, as defined here, is the same thing as in some other page called jobs, called a professor, and that thing has a thing called a place of work, and here's his, right? Very simple information, okay? So what's happening now is a bunch of links are talking about other things, but now if you want to know, well, what is a person, right? What do we mean by he's a mind calling person? I would actually sort of go over here to this page, and would give me something readable. Okay, and originally that was going to be human readable, and then with languages like RDF schema and OWL came along, we were putting machine readable things. So the machine would actually be able to get some inferences out of that. And then the last thing you need to really understand the semantic web technology is a way to say, well, okay, so this guy was defined on this page one way, and he's defined on this other page a different way. So we just need some way to say they're the same thing. Now, you can go to the International Semantic Web Conference proceedings. You can read hundreds and hundreds of papers about about why everyone is using that same as wrong or right, or what it means, and you know what all the theory behind it is. The real world uses it a very simple way to say these are talking about the same thing, right? And you can make whole patterns of those and stuff like that. Well, once you can do that, you can do a whole lot of things, and you organize those links in various ways, and I decided not to tell you about that today. But the talk I gave last week is up on SlideShare. Again, just use my name in SlideShare, or that's it. So that was the talk I gave last week, and I go through some of the different views of ontology, and a lot of the controversy in the first decade over the semantic web was, you know, sort of what should those pages of information that are in the machine readable form look like? What kind of information should be there? What do we tell computers? What do we need them to do? What kind of reasoning do we want them to do? And should it be complicated? And should it be simple and things like that? And I'm going to ignore all that today, right? But what happened is people started creating a bunch of this stuff and also linking it together with those same as links. So now you start to have, so if you search for me on one of these various semantic web search engines that nobody uses, no normal user human would say, I want to go search on the semantic web. It would be an app would normally say, all right, I'm looking for the references to this person, so I want a machine read it. But essentially it says, if you found me through any one of these URIs, right, so like this whole group is me in Sightseer, and there's another whole group that are me in ePrints, and there's another one that's me in DSpace. It starts to say these are all the same person. So where Les was joking about all the different things you can see about me on the regular web, when you pull that and try to guess, and he didn't even show you the many of them that are defamatory, ugly. I was very pleased with this set of photos because there are many out there that look much worse. And then of course all of the people who have, you know, I'm not the only Jim or James Hendler in the world. In fact, it's already a problem because if you Google me as Jim Hendler and you Google me as James Hendler, you get slightly different things. Although once upon a time you all got the same thing, now you all get different things because Google is personalizing your search results anyway. So if it figures out you're a computer scientist, it's going to show you different results than if it thinks you're someone else, which is, I'll get to in a minute. Okay, so some of you have seen this picture, what's called the linked data cloud. And what happened is, after we started creating these things with these sets of information and these links between them, a group in Germany said, why don't we start collecting these? And they went to Wikipedia and started organizing Wikipedia, so they created something called DBpedia, which many of you heard about. DBpedia went from a sort of toy project to, excuse me, to a fairly large system, to now it's actually supported by Wikipedia, is used by apps all over the world. So it gives you a sort of machine-readable version of Wikipedia. And then it started expanding out. So this cloud is the life sciences cloud, and publications, and music, and government, things like that. And there's a whole lot of stuff out there. Now, one thing that confuses a lot of people is this is one particular project's shared open data by a bunch of researchers, right? So some people say the size of the semantic web is, right, this number of links, whatever it may be. And that's not true. This is just a project. Okay? In fact, now if you go to these things, you will find a lot of really cool, great resources and a lot of stuff that broke 5 years ago when the guy graduated and got his PhD and no one has ever maintained it again. Right? Half the Sparkle servers, the query servers for these things don't exist anymore. Half of them work every day and are fine, right? And no one has gone back and cleaned this up. Because we've kind of gone beyond that. There's a lot of people still doing this great source for theses and projects and apps, but it's not really what most people are doing with the semantic web. So what's really driving the current work on the semantic web has been the maturation of these technologies. They went from something that a few of us on campuses were fooling around with to stuff that the real world is interested in. And I'm going to talk about sort of two things out in the real world of this stuff. One is what's going on in search engines, just to convince you that, you know, this isn't anymore just this little academic thing we're fooling around with. And then what's going on in the open world of data, and that's going to mostly set up a talk that Nigel will give this afternoon, for those of you who will be here for that. But these technologies have been developing. So, circa 2010, I wrote an article saying that, you know, we were starting to see semantic search come along. And at that time, we had this list of all of these companies that were starting to be out there that were going to succeed at semantic search. Now, probably most of you have heard of none of these, okay? There's a couple of exceptions in here. This one called PowerSet was a small company doing some natural language stuff with some semantic technology. They got bought by a company some of you have heard of called Microsoft, and they got renamed Bing. Okay, so the heart of Bing was to actually take what Microsoft was trying to do with a traditional search engine and take this more knowledge or semantic-based search and put them together. Freebase up here was bought by a company called Google. Okay, and Freebase has the technologies they were building have become the heart of what's been the most successful semantic web application today, the Google Knowledge Graph. Okay, so to understand sort of the semantic web coming to Google, I find this a nice way to talk about it, right? So here's an article in 2009 written by Peter Norvig, who's the research director at Google, Alan Levy, who's their data expert, and Fernando Pereira, one of their big database guys, called The Unreasonable Effectiveness of Data. And these are a couple of the quotes for them from any past words, word combinations. That's all the representational machinery we ever need. And choose a representation that can use, so basically, I summed up Peter gave a famous talk on this, and I got in trouble on a blog for referring to it as his talk as, humans, we don't need no stinking humans, right? The computer's just going to learn all this stuff based on what humans are doing and what's on the pages and how they're linked together. We don't need any of that stuff. Well, this is Peter's talk in 2012, and I won't read it all to you, but he sort of says, you know, we'd love to have this stuff. It'd be really nice if there was this markup on the web, but there's not so much of it, so we're still mostly using learning. So it was, yeah, humans would be okay, but it's still mostly learning. Right? 2013, we have a keynote by R.V. Guha. Remember I mentioned that meta content framework? Guha was the guy who brought that idea to the semantic web. He was then working at a company called Apple. Apple was at that point not a telephone vendor, but a computer maker. And then Guha went to IBM for a while and Site for a while, but he ended up at Google, where he pushed the idea that getting this stuff right would be a big deal for search engines. That you really couldn't do all this stuff with machine learning. And if I had another hour, I would give you the lecture on why that's true, things like that. But he said something about this thing called schema.org, which is essentially, let's figure out a way to take this semantic stuff and make it easy enough that webmasters and the people who build web databases and web app developers can get their hands on it. So he called this light at the end of the tunnel, right? He gave another talk this year where he said, Google now finds embedded metadata on over 20% of its crawl. So that is, this, if anyone asks you, why did the semantic web fail? Right, because I keep being asked that question. And I say, well, you call it a failure if Google at that time he said 5 million of the largest search domains, not search sites, not pages, domains, right? Use schema.org. Use this little bit of the semantic web, right? If you do a Google search now, so let's start it with my search, but this is actually what you would see now. So here, well, some of you would see, depending what country you live in, where you are, your background, but mostly you would see the knowledge graph enhanced search. So you'd see my search, you'd see some information about me. If you click, it'll show you some other people. If you search for him, some other people you search for. Nigel, you're number 3 now. You beat out Albert Einstein used to be number 3. Which gets us to the next thing about this stuff, which is, okay, this knowledge graph is a combination of automatic learning and human in the loop, and is trying to get more and more human in the loop, right? So the semantic markup done by people is what Google wants. Now, I should mention, if I had time, I would go show you a little bit of schema.org and things like that. But what schema.org is Google started, it was 240, it's now about 250 little tiny packages of information. So it says, if you want to describe a movie, here's 10 good things to tell us about a movie. It's actually 22. Who created it, things like that, what page it's being described in, what was its title, who was its director. If you want to tell us about a sporting event, right, tell us everything you would tell us about an event, and then add the following things that refer to sports, which sport it is, what teams are playing. So it's a very, very simple kind of knowledge system where you take these little packages of information and you embed them on your web page around the thing. And what they were really designed for was to be easily inserted. So when you go to a web page, if you go to my home page, you're actually downloading some HTML that lives in a file and is what the original web was all about. That's almost never the case anymore. Usually what's happening is you're hitting some database somewhere, the information is being automatically assembled, and you're getting a web page based on the information there. So it's very easy for the people who do that to add these little tags into the fields that say, okay, so I'm pulling up information about a professor at Southampton. I can easily embed around it this little bit of information that says this person is a professor and they work at Southampton in this thing called schema.org. Why would I do that? Actually, let me jump ahead. I'll slide out of order. Why would I do that? Well, so this is from, there's an online site you can go to, which is for all the people who try to make money by advertising things on web pages, right? So it's one of the big search engine optimization blogs. And they had an article about schema.org, and they say, why would you do it? Well, first of all, you can help searchers find what they're looking for, make the web more useful to the world, increase the efficiency of search engines. Those I described as it's okay, guys. There's a socially acceptable reason. But here's why you really care. You'll get the displaying of rich snippets on your search engine results pages, and that will increase your CTR, your click-through rate. Those of you who know web economy, web is all about, I show you an ad, you click on it, I make some money, right? So what powers the web is this web advertising, and what's important is where your stuff shows up in the search engine. So what Google and the other search engines, by the way, I've been talking Google, but schema.org is a joint effort of Google, Yahoo, Bing, and 3 or 4 small search engines. So it's a joint effort by the search engines to say, get this stuff on. Facebook has a sort of competing thing, and they're technically competing, but actually if you go to the Facebook, what's called the Open Graph Protocol, you'll see some pointers back to schema.org, and if you go to most of the blogs about schema.org, they'll tell you, by the way, if you're using this, it'll also help increase your Facebook stuff. But basically, these are just some of the various things that I'm looking at. So Yelp uses this stuff, and it makes it so that when you see a Yelp review, when Google makes the little gist, they know what were the reviews, what was the price range. So Yelp has put into their descriptions this little bit of machine-readable stuff, and then Google has pulled that out and put it up here, recipes, videos, and then recently they've been actually making it so that it expands out that knowledge graph. So you as an end user can't do this yet, but if you were a big provider like IMDb, Netflix, Rotten Tomatoes, you can actually do some stuff so that when that knowledge graph comes up, embedded in it will be some information about your site. So this would be a movie. Somebody has searched on a movie. I'm sorry, the quality isn't very good here. You'll see it better if you look at the slides online. But enhanced in here is something that says, this movie had these reviews on these sites, and if you click on them, it'll take you to those sites. And now the site vendors have made it easier for Google to find the information, and Google has made it easier for the site vendors to do it. Okay. Why did Google move away from, what was the story that led Google from that 2009, we don't need no stinking people, to 2014, thanking people for helping increase our search? And there was a great article written by Peter Mika and some other people, he's at Yahoo Labs, where they talked about this. But essentially they say, nowadays, the modern search engine, 40 to 50% of the query volume is what are called entity-seeking queries. So I'm looking for information about a particular thing. I'm not looking for general information about, what is the University of Southampton? I want to know, who is this person at Southampton? What is this event? Right? I'm going to graduation. Where is something being held? So I'm looking for very specific information. Usually that information can be summed up in kind of one thing. So like my page had that stuff you saw on the side. Matt Damon's page has a lot more hits than mine. So you'll notice mine had what other people are looking for. His has movies and TV shows. So they're building out this knowledge graph in a lot of ways. And what they realized is they needed people to help them with some errors that were occurring. So Peter Mika gave a great talk at a search conference early this year, and I got permission from him. So all of these next 3 slides are, quote, confidential Yahoo information, which he's shared, copyrighted. So anyway, so this is what he called the importance viewing. So if you look at the knowledge graph on Vin Diesel, in Yahoo he was born July 18th in New York City, died January 30, 2014, place to be announced. If you know that Vin Diesel is still very much alive, you can see why this is a problem, right? So just something it read somewhere when it was doing its machine learning said this guy had died. And since we didn't know where it was, it said, that we'll tell you that later. So that looks pretty silly. This one's a little better. So here's Ice Cube, little rough-shaped piece of ice. So obviously it confused these 2 different definitions of Ice Cube, right? Some of you might also like this next one. So this was the page for the famous artist Michelangelo. Yes, those of you who aren't Ninja Turtle fans, it's another naming. So the problem is language and learning gets a lot of confusion. But when a human has said, this is the guy I'm talking about, and it's a TV show about a Ninja Turtle, and this is what I'm talking about, and it's a famous painting by an artist, the confusion goes away. So Yahoo found by getting, Google, Yahoo, etc. found, by getting people to put in this information, it cleans up a lot of these errors. So they're now trying to really promote getting the semantics. And now I've just told you the Google story. There's a similar story I can tell you from Facebook on something called the Open Graph Protocol. Oracle now supports this semantic stuff in its standard database release. So you now cannot buy the big Oracle databases that power all of the military apps, most of the almost hospitals, things like that. So anybody with a big database that they bought commercially is probably using an Oracle database. They all have these semantic extensions. Oracle now gives what we would once upon a time have called a semantic web tutorial, is now part of their basic training of database administrators. Because lots and lots of databases want to move towards graph-like things. We talked about, you heard a little bit about that yesterday. Here's a few other of the companies that are actually using on a daily basis this stuff. eBay, Adobe, Monster, Rotten Tomatoes, O'Reilly, Yelp should be there, Google, Facebook. So you know, it's really the case that these very simple versions of the semantic web are out there, are being used. A lot of it is embedded, so you won't see it up there up front. And there's a whole thing going on between web developers and application designers and this stuff. Now that I'm almost out of the original time I had, let me start the other half of my talk, which is, but there's more stuff we can be doing with this. So that's search, that's what's happening. So essentially what's been happening down at the bottom of the web, in the real apps, the social networks, things like that, the developers have said, this human-in-the-loop markup is very important, and so we're seeing more of it, and we can take advantage of it for a lot of things. But then what's also going on, and this started a little bit around 2007, 2008, but we're seeing a new generation of it, is application developers saying, as we move into the data space, we want this stuff too. So for this Age of Data summer school, right, it's really important to see where is this semantic stuff playing out in the data space. So I'm going to go through this pretty quickly. And again, I have several talks up on the web. I gave a Strata talk you can find, see, as sort of an 8-minute version of this stuff that I've given in the past. So it's out there. And I really want to do now is mostly summarize it, partly because we lost a lot of time while we were tromping around campus trying to figure out where we were getting to, and then the extra half hour while Les was going through all that nonsense at the beginning. But the reason I came to Southampton is not so I could stand up here for about an hour and then disappear. I'll be around the rest of the day, lunch, etc. Please come talk to me about this stuff. If your research projects, those of you who are in the summer school, wants to look at this stuff, I'll be happy to be a resource while I'm here. And you'll be getting some more on it later. But one of the things that's happened, and the good news is since Nigel's going to talk about a lot of this afternoon, I don't have to go through a lot of the background stuff, is governments around the world, starting roughly 2009, there were actually a lot of small government catalogs before that. The first major catalog by any government, the US released something called data.gov in June 2009 with 57 data sets. So you could go to this thing and get the raw data from it was, I think, 45 of them were from the Environmental Protection Agency, and there were some others, right? By September 2013, my group was scraping sites from around the world and had found well over 1 million data sets. So these are not pieces of data. These are things where you can go get the data, right? They're from companies or countries around the world. The 4 biggest sites are the United States. Now that's a little bit of a cheat because we're combining by country. So DataGov is the US DataGov is the largest of the single data sharing sites. I used to have a little asterisk in here that says that the UK actually has the best data sharing site, but I took it out because Nigel really hates this slide.
It's meaningless.
It's totally meaningless. It is totally meaningless. And again, so I make it very clear. Even though the UK is tiny and has hardly any data sets compared to us big countries, it's actually got the best stuff out there. Actually, that's serious. And partly because they spend a lot of time thinking about organizing the data for what it's used for, and then realized earlier than the other countries that it wasn't just about publishing the data, it was making the data useful and meaningful and things like that. So that'll be, I assume he's going to touch on a lot of that later. But the key, and the other cheat in here is the UK, because you actually have a really nice government structure that's able to actually take things happening at the country level and organize it, tends to have almost everything consolidating to the central data site. The US, this is actually from about 90 different sites around the country. So a lot of these may be the same data set. So in the state of New York, we collect a set of data and we make it available on our data sharing site. That data aggregates into a federal data sharing site from 50 plus states and municipalities and other entities around our country. So the same data shows up somewhere else, right? We in New York State took the information from New York City and pulled that up. So it also will show up in the New York City database. France has a very different thing. France, it's mostly census data, and they broke it up into lots of little pieces. So it's really one big data set divided into many different. Canada actually has mostly geographic data, and it's very well organized collection, but mostly what that is saying this city is here, and this city is here, and this town is in this city, and this mountain is in this town. So again, not exciting information. As I say, the UK, even though the number is small, has a lot of time put in. Here are just some word clouds to show you things. So the US, you can see a lot of the stuff is on environment, defense. What you're really seeing here is the US is arranged around a bunch of agencies, and those are mostly the names of our biggest agencies. UK, it was originally set up around transparency, so you see a lot more emphasis on disclosure and transparency, health, finance, spending, etc. Nigel's over there changing his slides for the afternoon to put back his slide. He has a slide. Nigel and I have a famous slide battle for years until I resigned, said he won, about sort of size versus shape. The other thing is a lot of these are starting to move to smaller municipalities. So New York City, if you went to theirs, what you see is it's mostly about education, school, community. So the stuff you care about in the city. So again, these different entities have these very different reasons for the data. And what everyone wants to do is they want to share this data to create applications, things that will help citizens, etc. I don't have time now, and I can talk to go into some of those motivations, but I'm sure you'll hear that in the afternoon talk. But one of the problems that comes along is how do you find this stuff, right? So I got 1 million data sets out there. You can't just Google for them, right? So we need organizing structures and things like that. The main reason we all think the UK has the best data site is because they've spent the most time thinking about making it so you can find the data and get to it and reuse it. A lot of the other sites are just, here they are, and you'll do some kind of keyword search and you'll find the right data. Well, that doesn't work very well. People have been playing with faceted search engines and things like that. And the problem is totally a semantic problem. Okay, so I was asked by the United States to help them find some data sites when there was the big famine going on in the Horn of Africa that would help them understand some things about the agriculture there, right? And we found some really useful stuff in some World Bank data sets that were about Africa. There's a whole set of data sets called AfriCover, but AfriCover doesn't organize in the same way. We found it under agriculture, and the Kenya site, which was a separate site, they didn't have anything under agriculture, it was under agricultural. And it turned out that actually the best site we found was that in the US, in our data, called crops. Okay, so again, all these different words used to describe the same kind of data we were trying to get our hands on, that's a semantic problem. And so where a lot of people are looking in this data space is, what kind of semantics can we use to organize it? The other thing that's important about data is it has much more value when you aggregate it. Lena, can I go? I'm supposed to technically be ending now, given the late start. I can have 5 or 10 more minutes. Yeah, it's good. Sure, why not? Okay. I'm told I have good precedent because Wendy did it yesterday. Of course, she's got a title and I don't. They don't give them out in the US, so I can't have one. Nor would I get one for that. So these are just some examples. These were actually all made in my university, but they were taking information from many different government data sets and mashing it together. In circa 2009, 2010, 2011, that's a lot of what people were trying to do, is how do we integrate the data from these different sites to do something. So here's just one example. One of my students, as some of you know because he's visited Southampton a few times, Dominic DeFranco, Dominic built this demo that was featured on the White House site and was a, they really were excited to show somebody was doing something with this first set of data. And what this is the ozone layer levels of different places in the United States. So this would say, in this place, a bigger circle means there was more ozone reported. Now this doesn't look like such a big deal. Any of you who are app designers know you can throw this together in 5 minutes, except for one thing. There's no data set in the United States that had all of this information, right? What had to be combined was different data from different places. So there was a data set that talked about weather conditions in different places and had these average ozone mappings. There was a set of EPA pages which could be used to say what sensors were located where. There was some data.gov stuff that had some other things that let you actually, given these pages, figure out where the things were, and then use some geonames and some other general web stuff to put them on the map. Right? So this little demo took 5 or 6 different data sets and put them all together, and it gives you a nice, usable result. And that's what people started realizing to do, and then you can use web stuff to get to external links. There's some social data stuff in there. Here's another one, right? This is, if you want to look, I'm sorry, it's hard to see here, but here you click on a country. So here we've clicked on Indonesia, and this is how much aid in dollars. These are rationalized to each other, so that's another whole story. So I've got US data that's in dollars, UK data that's in pounds from different years. You go to another website, you get the conversion factors, you put that in, and so now we can say how much aid was going in from the US and how much was going in from the UK and in what different categories, right? So this was really useful. You could see who was giving money about what, and now there was another version of this with 4 or 5 different countries on it. You could also go to a more detailed thing that we could show you for each of the different kinds of data, who is giving how much money. So one of the nice things is you can start comparing things that were never meant to be compared. Of course, that comes with a, let's skip that one. That comes with a little bit of a problem, right? Here's one of my favorites. So the US and the UK were both reporting crime information, right? And so this is, in the United Kingdom, in Avon and Somerset Constabulary, right? So most of you know Avon and Somerset are not really a very dangerous part of this country. This is the average number of burglaries per person. Los Angeles, the most dangerous city in the United States, reputed around the world for being a dangerous city, much less, right? The average per person, way less burglary. Now, that doesn't pass the sniff test. Something's wrong with it. As much as I'd like to claim that it's just because the UK is this horrible country where everybody's stealing everything else all the time, and the US is this nice, safe place, that doesn't seem to quite match our terms. So what's really going on here? Well, what's really going on here is that when you try to put this data together, you see the US violent crimes include burglary, and the UK crimes include burglary. So you just merge them on that, you just join them on that, and you can do these nice comparisons. Turns out in the UK, they mean something completely different. So in the US, they're reported after somebody is convicted of a felony, a major crime. In the UK, it's when anybody has reported a burglary of any level. At least this is our best guess based on talking to people. So if you called up the police in Avon and said, somebody stole my bicycle, right? And then later it was found, no, it wasn't stolen, you had left it somewhere different, you'd show up as a burglary in Avon. Okay? In the US, if you were arrested for stealing a car in Los Angeles, driving it around, you got caught by the cops, but you got a plea bargain that let you get with no jail time, it wouldn't show up in the database, right? So same word describing very different things. And so that's where the semantics comes in, right? So, okay, so I mentioned this one already. So this kind of discovery needs semantics. To be able to find the stuff you're using for, you need to know what these terms mean, right? To integrate the data, I talked about pulling these things together and these burglary problems. So how do I know whether this number in this database means the same thing as this number in this other database, right? I need ways to label that stuff. So where a lot of the thinking is going on in semantics today is how to do it. This is another example. In fact, we were at a meeting yesterday. There was some discussion of postal codes and addresses, things like that. This is from Hadley Beeman, who's a woman who works in the UK. We did some slides together at a tutorial, and she showed this example of you had to pull these data sets together so you could put the pothole map. They did an open street map version of the potholes in the United Kingdom. But the problem is the ordnance survey, which had all the information about where things were, the city councils that had where the potholes were in a particular county, and the Royal Mail, which knew how to sort of take these names, High Street, and these things, map coordinates, and link them together. So if you could link those data sets, right, you could do this kind of act. So again, that's just another example of stuff I was talking about before. So more and more people have been getting that. So I've been using the following acronym, which is to dive into data. So where do we need semantics in this data world? In discovering data, in integrating data, and I won't have time to talk about it today, but in validating and explaining data, right? So what's interesting is if you go to a traditional database course, you really won't hear any discussion of any of those things, right? You'll hear about querying data, you'll hear about using data. So once the data is all in one box, that's what traditional database science has been about. But it hasn't really been about how do you find different data from around the web and pull it together, right? So how do you find it? How do you integrate it? How do you check? So how do you make sure that that burglary issue doesn't occur? And then how do you either explain what you found via visualization or things like that? So again, now I see what happened. I had a bunch of slides I cut out and one. I had two open windows and I cut the slides out of. So that's why some of these slides are in your class. But here's another example, right? Statistical correlations between things. So one of the things that happens, if you can pull data from different places, you can often tell things. So you hear a lot about data analytics and predictive data now. The question is, how do you know what to put together? So we did some work in some smoking stuff, and there have been all these things reported about how different interventions, whether it's a higher price per, put taxes on cigarettes, or don't allow smoking in bars, or things, or put those nasty ads that say this stuff is going to kill you on the side of a package. And it turns out that there have been all these papers written about which interactions are important. It turns out when you can get your hands on the data, pull data from different things, and then actually do those demographic things to say, what percentage of the people in this area that I'm looking at are from different demographics? And what you find is you can get much more meaningful results. So this is a colleague of mine named Deborah McInnes. They reanalyzed a bunch of the cancer data, knowing nothing about cancer stuff, knowing only about the smoking data, only about prevalences and things like that. But they re-looked at the data, integrating it across these different things. And what they were able to show is that different of these interventions had very, very different impacts on different demographic groups. So teenagers were more impacted by one than another, and adults might be something, and different parts of the country. So in some parts of the country, these things had used. So all these things that were aggregating data and then reporting the averages made it really hard. A colleague of mine named Brooke Foucault has recently written a great paper called something along the line of finding the small data in your big data. Right, so if you take these big data sets, these social networks, these Twitters, things like that, and you look at what you're finding, and it's usually meaningless until you can start explaining this set of people who have this feature in common, or this thing. So again, the semantic stuff starts to come back into all of this. So the big question a lot of people have been asking in this world of data analytics now is, so how do we go from sort of what we can do in these big data to models and explanations that allow new understanding? So looking at data in science, engineering, etc. So, to conclude, the semantic web is real and growing. Its main use today has been in search engines, although, and again, I cut some of this out, but increasingly moving to social media. But where we're starting to see now a lot of call for new stuff to come in to really understand this stuff better is in this age of data. I hope I showed you why. The next thing in your schedule is Barry showing you sort of how to do some of this data linking stuff. And then this afternoon, Nigel's going to give you great examples of the real power of having all this open data out there. So I'll stop there. play with big data and have a big screen. Yeah.
So it seems like so it is being successful in the data vision, but as you say, it's more of a privatized vision that's where it's being most successful within the context of individual corporations or whatever. Yeah, Google, when I've spoken to them, have always never been very keen to talk about big data. That's what they're doing, which I've always found it strange, and I don't know whether there's something about power relationships there that they're keen to sort of monopolize in a way this new space. And you said that sort of big vision, that famous slide with different connected things. So a lot of those are potentially failing
again, those are research things that come there, get it linked in. So not everything that's linked is in the cloud, and not everything that's in the cloud is still supported. But it was a good example of what you can do with this stuff. Has motivated a lot. In fact, there's been a lot of discussions about going back and cleaning it up. The problem is a lot of the people who would be able to do that are people who can now go off and work at a Google or build an app, or our friend Denny, for instance, who used to do this stuff. He was in DBpedia, then Wikipedia, Wikidata, now is with this other company. Chris Welty, another well-known name. So when people tell you, Google doesn't want to talk about linked data much, but they're starting to hire like crazy. So those of you who are doing semantic web, you should keep your eye on that one. But that's part of the problem. But part of the problem is, the money again is in this advertising and things like that. So that, not surprisingly, once a way was found to pull this stuff together, the thing that sucks all of the intellectual capabilities on the web into this dark hole of putting your ads on the paper, suck this stuff.
And that's true of all these new domains.
Yeah, I have a talk. I decided not to get political today, but I'm working on a talk. It'll actually be shown at one of the various TED conferences in January. And it's based on a quote by a guy named Jeff Hammerbacher, who, when he left Facebook, said, the best minds of our generation are being used to try to get people to click on stuff. Right? And I actually am using that to launch into what those of you who are Southampton know about social machines, and you've heard a lot about Wendy talking about that. Why aren't we taking, why aren't at least some of us, those of us who would normally become academics and things, really need to stop helping put ads on web pages and start helping people do new things that will actually fix the world. And there's a lot of stuff again, that time that everyone has spent watching Gangnam Style, right? What if we could put that to good instead of evil? But how and where? And what are the models for that? What are the incentives and things? That's something we should be, as academics, studying. In fact, in the very first article that led to web science, I was lucky enough, Nigel, Wendy Hall, myself, Tim Berners-Lee, and our colleague Danny Weitzner wrote a short piece in Science magazine called "Creating a Science of the World Wide Web," and we were arguing that there's a lot more we could be doing if we could really understand and utilize this web stuff right, instead of just focusing on that. That said, Google has a lot more funding than I do. Right? When Chris Welty, who will be talking on Thursday, you should ask him that same question, decided to leave IBM for Google, and he's starting there this week, I think. He said one of the things that's really great to him is he never has to write another grant. I've been sitting here killing myself about how many grants I spend all my time. That's what we academics do anymore, it seems sometimes. And there's these other mechanisms, but it means you're going to use your stuff to sell real estate, to do things in Facebook, to manipulate which things show up when, because that's what's crucial. One of the things that's really interesting now is the virality on the web. Often depends on virality on the web. So a thing gets out there and it starts to attract attention. Well, that will cause it to attract more attention, which will cause it to attract more attention. So a lot of things just tail off, and a few things go huge. And people have been asking why, and there have been studies of this. But one of the things I've never seen in a lot of those studies is the feedback loop. So when you get your thing sorted by, you go to your Facebook feed, and it shows you one of your friends shared this video. If that video has been getting a lot more hits, it's much more likely to show up in your feed, which of course means you'll look at it, which will give it another hit, which will cause it to show up more likely in other people's feeds. And these kinds of things. And some of that extinguishes, some of that doesn't, and what causes that. So a lot of the people who are now starting to really look at these things are saying, it's really not these graphs of what's going on, it's the dynamics over time on that, and that at the moment is owned almost exclusively by these companies. So that is a bit of a frustration for those of us who'd like to do this research, and Wendy talked a little bit on Monday about web observatories and why we'd like to be sharing more of this data and figuring out academic ways to get some of this stuff so we can now get our hands on at least understanding some of this stuff. But at least with the semantic stuff, you know, there's always been that of it that's going into companies and that of it that's been out in university, and that's still going on. And again, stuff like the open data. Nigel, I assume you'll talk about some of the commercialization and apps and things. But even there, none of that yet has really been something where someone has created a huge, you know, $1 billion company off of that stuff. There's a few that are close, and often they take some government data and add a lot of other stuff. But those places where that's starting to happen, again, you see a lot more willingness to talk to the academic community, things like that. Then as they start to get more and more interesting. The last thing I'll say, because I'm getting all these nasty looks from someone in the second row, given the time, is lost my very effective. I'll tell you at lunch. So anyway, I think I'll take another time.
Do you have more questions?
You touched briefly on the subject of big data, and it reminded me the reference to that you made Peter Novick, starting from an absolute faith in full text search, let's say, just to simplify things, and then starting changing his mind. What can we do to help companies that have most of the funding that helps us studying this subject to actually change their mind as well and stop talking about actually big data and start talking about data done properly for change?
Well, so how many hours now? That's what so I'm now the director of something called the Institute for Data Exploration and Applications at RPI. It's a fairly large institute, although at the moment only has one person. we have 50 affiliated faculty, but only one employee. But we're really starting to work on answering some of these questions. But you know, I mean, there's a lot of dialogue going on between the companies and the universities, because of course they can't hire someone who can really help them unless they can get those people trained at the university with the right kind of technologies. But the technologies that are starting to be deployed in the companies are starting to be so far beyond what we're doing at the university, and that tends to push the university towards a more theoretical stance. So if you go up to Oxford and listen to Semantic Web Talks, you'll hear a lot more about the theoretical logics underlying ontologies. Or if you go out to most of Germany, not all of Germany, the Europe. So again, what are academics doing in this stuff? What we've traditionally done, looking at trying to name the basic science and things like that. But there's a lot of stuff in the middle. And in fact, the talk I gave in Montreal last week, if you find the slides on the web or the video, there's actually the soundtrack of the talk with the slides. One of the things I really talk about is what are some of the research challenges. And what I think is really a research challenge is we as academics have to figure out how can we start answering these bigger questions, not what does reasoning look like in some formal sense, but if I was doing semantic search, how do I decide if I'm getting a better result? So what does it mean to use a knowledge graph? How do we start building knowledge graphs at a level that we can get our hands on them, because we're never going to have the 250 billion concepts that Google is talking about, right? 270 million, I think they're at now, something like that they're talking about going orders of magnitude, right? You can't crawl all that embedded metadata. There are some places now, a company called Common Crawl, and nonprofit. I'm technically on their advisory board, although I don't do a lot of advising. But they're really interested, you know, sort of they've made now available in the Amazon cloud an open source crawl. So you can get a lot of the page rank and all that. The problem is what you can't get is search histories. What you can't get is people's Facebook feeds. What you can't get is, so again, we're trying to talk about how do we take these big data things, turn them useful, and in a lot of the companies I talk to, you know, I got the same kind of answer that's really unsatisfactory to me as a scientist. They say, train your students on Twitter because they can get their hands on that, and once they learn how to do this stuff on Twitter, we can hire them and show them the real stuff, right? Because all these, you know, Facebook, Google, et cetera, don't really respect the, you know, so it's not, most of the papers written on Twitter, they could care less about. It's that the people who are writing those papers have learned how to use Hadoop clusters, have learned how to do big data analytics, and have learned how to do graph queries and build graph databases. And then they come inside and work on this other knowledge stuff, which includes this dynamic data that they won't share. So there's a big question about how we pull these things together, and you know, obviously it's something I spend a lot of my time worrying about. But I think the key is that there's a lot of web science to be done. This data space is much more open, right? Google has a beta site for doing dataset search using the schema.org dataset schema. This dataset schema was not in the original schema.org. It came from the semantic web community coming back to Google and saying, you know, for the open data stuff in government, we want a way we can do that same semantic stuff, and we proposed something, and went back and forth, and several of the big governments said, yes, we'll use this if you do it. And so now it's a supported part of schema.org. So again, it can be extended. All you have to do is convince Google that 1 million or more pages of really high-value stuff, or high-value means advertising, or some important user group will use it. So the two first extensions were the dataset extension and the genealogy extension, because the Mormon Church in the United States said, hey, we have all this genealogy data we share on the web, and we'll mark it up with schema.org if you'll make the search there. So again, very different use cases, but you know, external groups saying we want this stuff. So again, I think what we're starting to see is that you go to a data conference now, and at least the word semantics won't get you laughed out of the room. 5 years ago, I had a lot of fights with database people. Now they'll at least let me sit in the back of the room and occasionally say, yeah, if you want to know about that crap, go talk to him. And I think in 5 years, they'll all be saying, you know, when we discovered this data stuff and started putting semantics in it 10 years ago, because that's what usually happens when some community finds some other communities for doing something useful. And you're starting to hear that. So if you go to the very large database conference now, a lot of RDF data is starting to show. They have their own model of RDF, which isn't exactly the same as the one out on the web, but you know, it sort of gave them a whole new way to look at graphs. And Sparkle has become, in the supercomputing community, the standard graph database query language, even though they don't use RDF anywhere in anything. So again, a lot of the stuff we've done in the academic semantic world is making impact, not just in the Googles and things like that. So I'll stop there.
Well, let's thank Jim then. Thank you very much.